All right, we're gonna get started here. Good afternoon. I'm Mike Stair. Ed Hope's here in the front row. We're from AT&T's Chief Security Office. We're both leads in our cloud security organization, and we're gonna talk to you today about an open source tool you can use to secure your OpenStack projects. So this is gonna be a security talk. Some of our other AT&T colleagues are also talking about containerization and quality assurance, so we encourage you to check out some of those sessions. So this is our agenda. We're going to do a quick overview of SecurityMonkey and how we got involved in that project. We'll talk about the internals, so we'll go through some of the architecture. We'll talk about our OpenStack integration, and we'll end with a live demo. So SecurityMonkey is an open source project. It was released by Netflix back in 2014, primarily then to monitor the security posture of all their different AWS accounts. So Netflix, as a company, is pretty committed to open source. They have hundreds of repositories out on GitHub. SecurityMonkey is part of one of their project suites called the Simian Army. One of the more famous is called Chaos Monkey. It helps test your resiliency by actually randomly taking down EC2 instances in your production environment. So really seeing what your standby and failover capabilities are. There's even Chaos Kong now, which takes out entire regions in production. So pretty aggressively seeing how ready you are for disaster recovery. So Google came along later and added GCP support. And we're obviously here today to talk to you about the work we did for OpenStack. So what it does at a high level is it monitors all the different cloud technology, all the resource policies, and it's looking for anything that's insecure or non-compliant. So let's define two terms I'll use throughout the talk. That importance in SecurityMonkey. So the first one is an item. So an item is an instantiation of a cloud service technology. So a specific security group, a specific network, a specific instance. And when we hear issue, it's when a configuration of one of those items, one of their policies, is failing our business rules. So it's out of compliance or it's insecure. SecurityMonkey keeps a historical inventory of all your items, their full life cycles, anytime an item's created, any and every change that's made, and eventually if you delete that resource, and then all the deltas. So whenever there's a configuration change, you can go back and see what changed and when exactly did it change. So when you do have an issue arise, there's notification services. So any of the interested parties, your operational team, your security team, the account owner is aware that there's an issue with a particular configuration. And there's also support for justifications. So if for some reason you have an issue, but you want to put an exception in to allow that configuration to stay active. It uses this scoring system based on issue severity. So you have higher and lower priority issues. It's got a highly dynamic web user interface. So it's really driven off the database values and also some of the middleware source code, which we'll show a little bit later. And it's extendable. So if what's available in the open source distribution doesn't meet your needs, it's very easy to extend it for your custom requirements. So we really started getting interested in it for two main reasons. So first, AT&T is really embracing public cloud adoption, all of them. So we also still have a large private OpenStack presence. So we're looking for tools that really handle multi-cloud, right, to limit the need for integration and support. And the second is open source. So we're also really aligning to more open source values, not only utilizing, but also contributing and becoming part of the open source community. So next we're going to actually go in, talk about how SecurityMonkey works. We'll go through some of the architecture. So this is a kind of high-level reference architecture for SecurityMonkey. So along the bottom there, we already talked about the three major cloud providers that are supported. And then at the next layer, those common cloud services really across all the providers. So things like identity, compute, network, storage, and then obviously you tend to have these cloud-specific services that we handle. Those all get referenced across the well-published APIs and various SDKs. So for AWS and GCP, they use the Bodo client. We'll talk a little bit later about using the OpenStack SDK for our integration. And then along the top, those are the three kind of major capabilities that you have in SecurityMonkey. So one is around inventory. So having awareness, having visibility into all your resources, all their configurations, so you really understand kind of your overall security posture. The second is audit. So the ability to run checks against all those different configurations to make sure you have everything's secure and complies with your business rules. And the last here, notification. So when there is an issue, the ability to inform whoever needs to take a look and see if there needs to be any changes made. We'll talk about the single sign-on providers later for some authentication, clearly notification services, so how those notifications make it to the proper places. And then over here on the right, the portal, again, is basically the main interface into SecurityMonkey. This is the technology stack. So let's start on the bottom. Postgres is the database of choice. It's storing all the items, all the configurations. Redis is used as a message broker, and we'll get into that a little more. It is predominantly a Python-based project, so it has a lot of different Python dependencies. I'll call out two main frameworks. So one is Celery, and Celery is a asynchronous job broker framework, and Flask is pretty common use as a micro web framework and also for the API server. And then the user interface is written in Angular Dart, and we use Nginx to proxy requests to the UI. So we talked earlier, we had inventory, we had audit, and we had notification, and those directly map to these core components called watchers, auditors, and alerters. So the watchers are what actually going out, they're polling all the different services, looking for all the inventory, looking for all the configurations. So basically on a interval, and we'll talk through this, so every 15 minutes, every hour, you're going out, you're pulling all the security groups, you're pulling all the network configs, you're pulling all the instances. There's a companion library called CloudAux that Netflix uses to really simplify the integration with the different libraries. So it just does things like multi-region support, connection caching, pagination. It does some normalization. It just really simplifies the SecurityMonkey code. So watchers produce items, and those items feed into the auditors. This is where you're validating all that inventory for compliance. You can associate one or more auditors with watchers, and they're also highly dynamic. So you can go in and change the scoring. You can enable and disable certain auditors. And auditors produce issues. Those issues feed into the alerters, and this is where you're getting that notification out. So out of the box, you get email support, and if you use Jira for your case management, you get auto issue generation, and then eventually resolution. So we talked about it being extendable. So again, if there's something in the open source distribution that doesn't meet your requirements, it's easy to add new functionality. So the first is account types. So if you have if you wanted to go so far as add a new cloud type, a good example here is GitHub. So someone recently added the ability to monitor your organizations, your teams on GitHub. You can look at repositories. You can check and make sure all your team members have two-factor authentication enabled, for example. You can extend watchers. So if there's a particular cloud service that isn't being covered, you can easily extend and add that service yourself. Same with auditors. So if there's a particular business rule that isn't being checked in the distribution, you can easily add a new check for whatever you want. The more common one I see is alerters. So if you use a SIM platform, so if you use Splunk or if you use like Elasticsearch, you can easily send those notifications into those platforms. And the same with collaboration tools. So if your team uses Slack, you can publish a notification into a particular channel whenever you have an issue. So let's map all those functional processes into the actual software itself. So in the bottom left here, pretty obvious, you have your database. That can be a local instance. You can use the database as a service for whatever provider you're using. Upper left, you can scale out your user interfaces. You can load balance across them. On the right here, we have our scheduler, our worker, and our message broker. So this is a pretty recent change to the architecture. The way things used to work is you had these big monolithic Python processes, and it would thread off these watcher requests to go out and pull inventory. And if you had a lot of accounts or you had a lot of items like some members of the community have, this became really resource constrained, used a lot of memory, did not scale well. So there was a change to move to more of a traditional job-based architecture, and we'll dive into that next slide. So it's pretty common, your scheduler, again, these are scheduling out those requests to go out and pull all the cloud technology inventory. And the scheduler is going to submit into the queue, technology A for account A, so really a specific watcher it wants to run. That goes into the queue, and then the queue gets distributed across the n number of workers. So you can really scale this out vertically as much as you want. A worker will receive a request to do a specific watcher job. It'll complete that and then go get a next job. So it's, again, a lot more distributed, a lot more efficient to scale out when you have a lot of different inventory you're pulling. There are Docker configs that are available. It's currently not recommended to use these on production, so more development and tests. There are some members of the community, though, that are working to improve these, so they are more production grade. We saw this, a lot of these map to what we talked about earlier, your UI, your API, your database, containers, and then we just spoke through the scheduler, the message broker. You again can scale out your worker containers, and you only really need to expose out the UI port on your host network. So when you go to use it, so the actual users who are going to log into your user interface, you have a couple options here. So first is you can create just local accounts for this particular instance of SecurityMonkey. It also integrates with a good amount of single sign-on providers. So one login, we have Ping, Activate, Azure AD, and Google, and you can assign roles for all your users. So clearly you can give them admin, which is super user, they can do anything they want. You can give the ability just to view any of the issues or items in the system. They can comment, or we talked about, they can do justification. So if they want to put an exception in for one of the issues. There's also a handful of command line tools you can use. These are mostly to manage SecurityMonkey itself. So you can add users, you can do database migrations if you update versions. You can run some manual auditors or manual watchers if you want to kind of run them out of the timing frequency. So that was kind of a view of how SecurityMonkey works internally. So now we're going to talk specifically about the work we did to add OpenStack. So this is a tool called Shodan. Has anyone heard of Shodan before? Any hands? Right? Okay, good. About half. So it's basically scans the internet looking for exposed services, and it makes provides basically a web service or a search engine looking for IoT devices or anything that has exposed services. This particular screenshot is looking at one of the public OpenStack providers' web block and looking for port 22. So effectively, we're looking at any projects running in this public OpenStack cloud that have SSH open to the internet. So typically not best practice to have remote access protocols internet facing. You can see here there's a little over 2,000 available. We see versions, we see some public key information. This is the exact same net block. This time we're looking at RDP traffic, so another remote access. What's a little interesting here is I obfuscated it, but if you have your fully qualified domain name in your certificate, you can actually see who owns this VM, whose VM this is, let alone it being exposed potentially for compromise. And again, looking at MySQL, a couple hundred, internet-facing MySQL servers, same net block. So kind of the point making here is that I'm going to assume that maybe a portion of these project owners are not aware they have this exposure. So having a tool that really gives you that visibility on what your services are, what your configurations are, really makes you have a far more secure project. So we started looking at what capabilities made sense, at least from my initial release, to put into SecurityMonkey. So what we currently have are Nova instances, a bunch of Neutron, so clearly security groups. We added routers, networks, subnets, ports, floating IPs. And then Swift, we put in support for object containers. These are the associated auditors that run against, again, all the inventory collected by those watchers. So the big one is security groups. So we're looking again for anything that's internet accessible, both inbound and outbound, that are to any source. So 0.0.0/0. Subclouds have this as none if you don't supply the source information. And then unknown access. So this is an interesting feature that SecurityMonkey has, where you basically can whitelist all the networks you use for your security groups. So you could say, this is my corporate WAN, these are some contractors, these are my vendors. So you really get a better understanding of exactly what your exposure are because everything is mapped to what the access is. So for object containers, certainly in the news, you've seen a lot about public exposures where you have internet or publicly accessible object container that maybe has customer data, has client data that people weren't aware was sitting internet facing. So we look at the ACLs and see if we have anything that's world readable, writable, or listable. And there's certainly scenarios where this makes sense if you have static websites, but that's where you have the justification process to explain exactly why this thing is internet facing or open, publicly accessible. Here's how we perform the integration. So we're using the unified SDK. Your credentials, your authentication is through the OS client config files, the clouds.yaml files, and it supports obviously v2, v3 password authentication and all the vendor profiles. So everything that OS client config supports. We did a lot of work to do CloudAux library integration, just to follow the same example as they did with AWS and GCP. It really simplifies the security monkey code itself. And then role-based access control. So this is a monitoring tool. Just give it the permissions it needs. So it just needs read-only. So if you're in the public cloud, you create a dedicated read-only user account. If you're in private, you can do the read-only policies, define them per OpenStack service. And we have some notes on that out on the SecurityMonkey GitHub. All right, so now we're actually going to get into a live demo, which will be fine. Everybody saw the keynote. Everything's good. So let's set this up. So on my local host here, I'm running the Dockerized version of SecurityMonkey we showed earlier. I'm running a Dockerized demo of Jira. And then I'm going to interface with a Rackspace account. It's pretty lightly populated so we don't clutter everything up. And we're going to use the existing Keystone authorization and then the various service access endpoints to pull in our inventory. So the scenario is I'm going to take you on a quick tour through the SecurityMonkey GUI just so you get an idea how it works. Then we're going to go through the Rackspace command line API and we're going to create internet-facing RDP security group. We're going to pull that in. We'll see SecurityMonkey create an issue for that. It's actually going to open an issue in Jira. We'll go in. We'll put an exception in. We'll put a justification in. We'll see Jira auto-close that issue. And we'll just give you an idea of kind of a common use case in SecurityMonkey. Let's see this shown, right? Okay, so let me introduce you to some windows real quick. Up here, this terminal up here we're going to use to run the Rackspace API. On the bottom, this is a special container called data, and this gives you a shell into SecurityMonkey so you can run all those monkey commands that we talked about earlier, and I'll show you some examples of that. Well, this is Jira, and just proving to you there's no open issues, so this is clean. And then this is our SecurityMonkey login page. So you see, if I had single sign-on enabled, that's where you would have your option to log in. I'm just using a local account to log in. All right, so let's start in. Just hope it's a little bigger, maybe. Is that good in the back? You guys good? So let's look at settings first. This is my Rackspace account. So this is where you actually put in your project details. And when you have an OpenStack account types, again, we talked about what's available. You provide it just a name. You provide it the path to your clouds.yaml files. This would be on the host running SecurityMonkey. And then you provide it what profile you want to load from that clouds.yaml file. You also have to click this checkbox that says to activate, to actually scan. So you can have accounts that are created in SecurityMonkey, just not actively scanning. If we go back into settings, on the left side here, these are the notification settings for this particular user. So for my local account, you can have three options. So one is anytime there's a change at all, I would like to get an email. That can get very noisy, obviously, if you certainly have a lot of different items. You could say, just send me an email whenever there's an item that has an issue. And you can then say, you know what, I don't want any emails when there's a change, just send me some daily digest. So through the daily email. So we have a bunch of tabs up here. I'm not going to go through all of them, just to point out a few things on how flexible things are. So these are a couple of my auditors. You can go in, you can disable specific auditors, you can go in and disable specific checks. You can modify the scoring, so if something coming out of SecurityMonkey you feel is too low, you can increase that scoring threshold, so a lot of flexibility. Here's the network whitelisting we talked about. So I had whitelisted a network that I created in Rackspace called OAM that's used in one of my other security groups, so it doesn't flag it for that unknown access we talked about. You can ignore if you have a really chatty item or technology, you can ignore it. You can see users. I do want to show you this, this watcher config. So this is alphabetical and it's every watcher regardless of cloud. So you see a lot of AWS and GCP. It's alphabetical, so all the OpenStack, I hope you can see that, is prepended with OpenStack, so go down to O. And from here you can enable and disable individual watchers. You can change the frequency in which they pull. So here's your options out of the box. Every 15 minutes. If you have a private cloud and you don't have Swift enabled, you can just disable it. Or if there's something you don't care about, if you don't want to, take inventory of all your routers or all your networks, you can just turn all that off and just turn on exactly what you want to see. This is the dashboard. So this is like the single pane of glass, if you will, of all your accounts. So if I had multiple accounts, there'd be a list over here on the left. You can look in the middle and see for a particular technology, what are the overall scores. You can see on the right here, upper right-hand corner, a little more detail about your high-scoring items. And then this bottom right one that's empty would be populated if you actually had any outstanding issues that haven't been justified or resolved. So we are going to, again, we're going to create an internet-facing security group, RDP. So I scripted a little bit to help. So if everything works, this should create a security group. And now I want to add a rule. So we're going to create a rule that says port 3389. And since I'm not supplying any source information, it's going to be internet accessible. So that should run. So we created it, ingress 3389. Down here is that shell we have into the monkey commands. So if we run monkey, we get a big long list of all the possible options you have. You can add accounts here again. We really want to focus on two. So this one is audit changes. So again, the frequency we saw was every 15 minutes, every hour, and I don't have 15 minutes or an hour, so we're going to run these manually for the demo. So run auditors. And this one runs the watchers, so you can run a manual full cycle of the watchers. So since we just created that security group, we're going to run a monkey find changes. This is going to go out and look through, again, my Rackspace account. It's going to look through every region, so it takes a little bit to kind of iterate through the regions. And it's going to pull in, again, any new items. It's going to pull in any changed items, and it's going to find any deleted items, and it keeps track of all that. So it should be completing. We can see here, I have one created, so we created that RDP. If we go back into SecurityMonkey, refresh, down here on the right, we now have that aging issue. So we have an internet accessible with a value of 10. If we go into Jira, we do a refresh. We see we now have an issue opened here. So internet accessible, Rackspace's account. It's actually probably hard to see this. It's in the open state. You get a little bit of detail that was automatically created. You can drill down. It'll bring up any of the outstanding issues. You could ignore this green one. This was my contingency plan if I had connectivity issues. We're going to drill into the issue itself. So you get a little more detail. Up here in the left, you have a little more detail about the name. I got the UUID. I have what region it's in. Up here right, you can have comments for this particular item. So multiple users can discuss this particular item. You see here in the middle in the red, this is the issue that was raised, that we got the ticket on, so internet accessible. Down here on the bottom right, you get a JSON representation of the API result, basically. It gets normalized a little bit. If we had created multiple rules, if we had changed this item, we would have on the side here on the left, we'd have multiple entries. We could click on those, we could do diff, and we could see exactly what rules changed, what was added, what was removed. So really a lot of detail here on all the different items. So we're gonna justify this. So I'm gonna say, this is a threat team owned honeypot, so it's fine. It can be internet accessible. We'll click justify, and go back into the dashboard. We see the issue's gone. Now we gotta run our auditor, because we gotta tell Jira now that we made a change and they can go ahead and close that issue. So we run monkey audit changes. You'll see here it says it's syncing the issues with Jira. We'll go back in, we'll refresh. We see now the status has been closed, and we see we have no outstanding issues. So again, just nice integration with one of the case management tools. Again, you could extend this if you're using some other platform. So hopefully I gave you a good introduction to what the UI looks like, a good example use case of justifying or resolving out an issue. So this is the to-do list. So specifically for OpenStack, kind of the wish list. The first one is orchestration. So the way that it kind of works today is you do a clone of the SecurityMonkey GitHub, and you do a build, and then you may plug that into whatever you use to push out code. I think it'd be interesting to have some examples, maybe some heat templates, maybe some Helm charts or Terraform of how you can orchestrate out SecurityMonkey itself. Adding additional watchers and auditors. I've started on some of these. So, potentially maybe you only want to allow golden images in Glance. So you want to alert if there's something that's non-compliant. This second one's probably more for private cloud, but let's say you have a public network that assigns floating IPs, and you want to know if an internal VM has a internet-facing floating IP assigned to it. And then the bottom one here, just potential for integration with native OpenStack services, so some of the databases as a service or some of the new container projects that are out there. This is kind of the community cloud agnostic to-do list, if you will, and the top two are really mine. Organizational view, so the visibility or you're really at the account level, at the project level, and it'd be nice to be able to do an organizational view, like roll up a handful of projects and look across them and see what the combined issues are. The second one is auto remediation. So obviously automation is a big topic now in security. Potentially the ability to, when you do have an issue, you can revert back to the last known good state. A UI rewrite from Angular Dart to React. I'm not a UI developer, so I'm staying out of it, but apparently most of the community thinks that it's a little difficult to develop in Dart. This is a big one, event-driven. So polling is obviously inefficient. The way it works now is going out and polling through the APIs. Netflix started a new project called Historical, which is AWS specific, but to really move a lot of that watcher logic to be more serverless, more event-driven. It'd be interesting to know if there's opportunities in OpenStack, maybe something with some of the Oslo project, or maybe there's something more appropriate to really move away from kind of that current polling logic we have today. And then finally, documentation, because no one ever wants to write documentation, so looking for people to add it. One of the main ones here I've seen people say is explanation of issues. So either in the UI or the documentation, can we have a better way to explain this to maybe people who aren't quite as security focused on what exactly this issue means, instead of just saying your internet accessible SSH. So we got to give a shout out to Mike Grima and Patrick Kelly. They're the SecurityMonkey leads at Netflix. Just very supportive of our effort, very helpful when we had any questions or any issues during our integration. This is the link to the GitHub. So SecurityMonkey, check that out. And then they use Gitter for collaboration. And again, there's always a lot of members of the community out there willing to answer questions or help you get set up. So like to really invite you to come contribute, be part of it. I'm sure there's a lot of things we can add to make this a more useful tool for the OpenStack community. And I think with that, we will open it up for questions. There are microphones, kind of here in the both sets of aisles.
Thanks for the talk. It's really interesting. I'm curious how you're using this at AT&T. Is this to monitor your private cloud, or are you doing this in a public cloud context as a service provider? Or do you know of other service providers exposing this to their customers?
Right, so we're doing some internal evaluation. So we do have some other capabilities that there is some overlap. So we're doing a little more proof of concept and seeing where this fits into some of our private cloud security. I don't know of really anyone, especially other internet service providers that are currently using this. I know there are a handful of community members throughout kind of the world who are test driving the OpenStack integration part of it. But cool. Yeah, thanks.
Security groups are obviously the big component that are going to be monitored. Is there any intention to look at the group-based policy in this setup?
So we kind of went after that low-hanging fruit, right? So security groups, the S3 object containers, but yeah, there's certainly a lot of opportunity to add that other group-based policies to look at that. And if you want to talk about it after, it'd be great to understand, if you have any ideas on what that would be.
Great, thanks.
For the remediation, are you planning on using Ansible or some sort of Ansible integration with SecurityMonkey?
Yeah, I haven't thought through a lot of how we would do that. Again, today it's a read-only tool, so you would need some way to orchestrate that back. The way that I actually developed it, though, is a little different than the way that AWS and Google did, which is we talked about that CloudAux library. The way I wrote it is you could actually, instead of losing, so they lose some information, the other clouds, you can take the representation at SecurityMonkey and it's ready to send back to the API call. So I'm not sure. So the foundation's there for it. I mean, we have to think through a little more, exactly what mechanism you use to push that out and make that, again, that right. Because right now it's read-only. Yeah, good question. All right, well, thank you very much.